let's continue with Kirchhoff's rules. Understanding Kirchhoff's rules. Now here I consider a circuit, a network having three EMFs, E1, E2 and E3, and five resistors R1, R2, R3, R4 and R5. Now E1 and E2 are supporting each other and will be sending current in this way. That current is I1 and reaching at A. Same time you can see that the E3 derives current along this way. Both the currents are meeting at this point and flows out along this direction as I3, and it completes reaches here, and that I3 splits into two as I2 along this way and I1 along this way. Now when you do the splitting here, in one path only one current flows. Okay, so I2 will come along this way, I1 must flow along this way. Now, actually A, B, C, D, A, this is a big loop here, and there are two small loops here. So like that you can have three different loops. Now applying Kirchhoff's first rule for junction A, we can see I1 reaches here, I2 reaches here and flows out as I3. That means I3 equal to I1 plus I2. And at junction C, I3 is reaching there and splits into one. So I3 equal to again I1 plus I2. This is the first rule. And that's a simple one, there is no complication. But second rule, that is the loop rule, that is what we are supposed to understand clearly. Now this loop rule we will be discussing based on the loop that we define. First of all, if I define a loop A, B, C, D, A, the big one, A, B, C, D, A, and I move from A to B, B to C, C to D and D to A. Along with sign convention, I will be writing plus I1 R1 against the direction of flow of current. Crossing the cell from positive to negative, minus E1. Crossing the cell from positive to negative, minus E2. Plus I1 R2. Then the current flowing through this path is I3, therefore plus I3 R5 here D2A plus I3 R4 and D2A means we are raised back to A. So A to B, B to C, C to D, D to A. So because potential difference between A and A is what? 0. Okay. Now you can take that I into R on one side and EMF on the other side. So when I take it like that, I1 R1 plus I1 R2 plus I3 R5 plus I3 R4 will be equal to the other side E1 plus E2. Now this is the Kirchhoff's rule, the loop rule for the loop A, B, C, D, A. Okay? So when you move from A to B, B to C, C to D, D to A, it's coming like this. Understood? Okay. Now, if somebody is taking the reverse order, reverse order, if I take it, the reverse order format will be A, B, C, B, A. A, B, C, B, A. You can see the change here itself. When I take from A to B, following the direction of flow of current, in all this you are flowing along the direction of flow of current. Therefore, what happens is, you see, this becomes negative. Okay? Sorry, let's start from this end. I3 R4 along the direction minus. Here also negative. This also negative. But when it comes here, you will be moving from negative to positive through the cell, low to high. Then that will be plus E2. Like that, here also plus E1, and here again minus I1 R1 will be equal to 0 because we are reaching back to A. Understood? Okay. Now, if again you take that I2 also on one side and EMFs on the other side, then you can see the same thing you are getting. Okay? So whether you have taken the circuits in the clockwise form or in the anti-clockwise form for the same loop, the loop rule will give you the final results one and the same. So there is no question of taking whether it is in the clockwise direction or in the anti-clockwise direction. That at your wish. Okay? Now like this you can practice another loop. For example, let us define the loop. A small one in the state. That is A, B, C, A. A, B, C, A. A, B, C, A. Okay? Now start writing A, B, C, when I take direction of flow of current. Is in this way, A to B means against it. So again you say and minus I1 R1 plus, sorry, 1 minute, against the direction of flow plus I1 R1. Okay, then minus E1, again minus E2 plus I1 R2. Then when it comes here, C to A, current is I2 along the direction of flow. That means minus I2 R3. Then crossing it from plus E3 will be equal to 0. So when you take the small loop here, remember two different currents are coming. Okay? So when it reaches here, it will be equal to 0. Now, rearrange that, you get I1 R1 plus I1 R2 minus I2 R3 equal to, means I into R from one side will be going to the other side, that E1 plus E2 minus E3. Now this is the Kirchhoff's rule for the small loop. Okay? Now if I reverse it, if I reverse this, by now you all might have understood how to. Let me take it in this way, that A, C, B, A. Like this I am moving. From here itself you can understand. This becomes negative, reverse order. This becomes positive. this becomes negative, positive, positive, and this negative. Reaching back to A itself, that's equal to C. Now, rearranging them, I into R's on one side and EMFs on the other side, you will be getting the same old equation. That I1R1 plus I2R, I1R2 minus I2R3 equal to E1 plus E2 minus E. Now, like this, any network we can apply loop. Here I leave one loop, that is A, C, D, A, that you can work it out how it must be. Okay, that's all about understanding Kirchhoff's rules.